Oh, you don't want that one? Oh, bummer. Okay, there we go. Now we're back again. Everything seems to be right. This is Tech Math 2. And we're doing a final exam review. That's what we're doing. It might take 2 days. It might only take 1 day. But that's our plan. All right, so first problem. And we'll do 2 at a time, just for the heck of it. So the first problem, I've got 38 truckloads did 55 patios. How many truckloads does it take to do 140 patios? Solve for x. So x is going to be cross multiply 140 times 38 divided by 55. And anybody got that answer yet?
Yeah.
What is it? C. All right. Temporary storage. A temporary storage corn is dropped into a parking lot, giving a circular cone. Now, luckily, the back and front covers of your book are usable, and it says of course, the volume of a circular cone is. And if you want a formula, you can ask for it too, but I'll probably tell you, look in the back of the book, something like that. All right, so that's the formula we're using. So I've got 1/3 pi. The height of the, you gotta be kidding me. Radius, the base, the circumference is that. All right, so if the circumference is that, C is equal to pi to r. So r is equal to the circumference divided by 2 pi. Okay, so we want 50.27 divided by, that's the circumference, divided by 2 pi. And that makes it the radius, and then we're going to square it, and then the height is going to be, oh, it's 9.5 feet. I thought that said 9,500 feet. That's a whole lot of corn. And anyway, so I put the 50.27 divided by 2 divided by pi in my calculator first, and then I'd hit the square button once I had an answer for it. Times pi divided by 3 times 9.5. And it looks like I got 636.81 cubic feet. And looks like that guy there probably is the right answer, A. Okay, is that all right? Just remember, front and back cover is always usable on a test, so don't be doing anything weird. Problem number 3. The side A of a right triangle. Find side A. Okay, so I draw a right triangle. And this guy is 0.632, and the angle 18 degrees 6 minutes 45 seconds. And I want to find side A. So that's this guy here. So that would be a sine function. The sine of 18 6 45 is equal to A divided by 5.632. So A is going to be 5.632 sine 18 degrees 6 minutes 45 seconds. And now it's a matter of, can I put it in my calculator? All right, so 5.632 times the sine of 18 math degrees, minutes, seconds, degrees, 6, math, degrees, minutes, seconds, minutes, 45, math, degrees, minutes, seconds, seconds, close parentheses, boom, and I end up with A is equal to 1.75 kilometers, and it probably rounds off to 1.751, so I would go with D. Okay, can you make your calculators do that? If you can, that's good. If you can't, then you want me to show you a different way? I do have other ways to do that problem. All right, back to find the equation of a line passing through that point perpendicular to that guy. So first thing we need is to put this guy in slope-intercept form so I know what the slope of this guy is. So minus 3y is equal to minus 4x plus 8. Y is equal to 4 over 3x plus 8 over 3. So the slope of this guy, of the original line, is 4 over 3, but we want the slope that's perpendicular to it, which is going to be minus 1 over m. So that's going to be minus 3 over 4 is the slope of the guy that we're looking for. All right, now in the front of your book you have a point slope formula that says y minus 6 is equal to the slope times x minus a minus 12. Yeah. And then we're going to take that formula and turn it into something that's useful. So y minus 6 is equal to minus 3 over 4, x minus minus minus, 4 goes into there 3 times, minus 9. Okay, now we're going to multiply everything by 4. 4y minus 24 is equal to minus 3x minus 36. 3x plus 4y is equal to minus 12. Do we have one of those? 3x plus 4y is equal to minus 12. It's obviously sitting right there, but I took away the right answer on purpose. So what we would do in this particular case is write the right answer down. 3x plus 4y is equal to minus 12 in the space provided. But yeah, I expect things like that to be there because I'm one of those types of guys that would do something like that. It'd even be worse if I let Ben proof the test for me, right? All right, so we got to simplify what we have. Okay, so I got x minus y cubed. I recognize this as x plus y squared, and I'm divided by x plus y squared, and I recognize this as x minus y squared. And then I get out my red crayon, and those guys go away, these guys go away, and all I have is x minus y left. That sort of looks like the C answer to me. Right. Now the front of your book is going to tell you that x squared plus 2xy plus y squared is x plus y squared, right? So that shouldn't be a mystery to you. But it probably will be. Unless you have a better calculator than my TI-36, this is going to have to be done manually. So that's a problem, almost as bad as that. But luckily there's so many zeros there, it's gonna come out in the wash pretty quickly. Okay, so we're gonna choose to expand on this row. Okay, so that's gonna be minus 1 raised to the row, 1, 2, 3, 4, plus column, 1 for 5, times 0, times some remaining 3 by 3 that I don't have to write down because I'm multiplying by 0. Plus minus 1 raised to the row plus column, 6, times 0 times a 3 by 3, which again I'm not going to write down because it's going to be 0. Minus 1 plus a minus 1 raised to the row plus column, which is 7, times minus 4 times the minor that is remaining. So I remove that column in this row, and what I have left over is minus 5, 0, minus 3, 8, 2, 0, minus 7, 0, 1, plus something else times 0, which I don't have either. So the only thing I have left, minus 1 to the 7th gives me 7 negative signs, plus another negative sign makes it even, so I'm going to have 4 times minus 10, 0, 0, minus, going the other way, 7 times 6 is 42. It is 42. Okay. 42, 0, and another 0. All right, so that's what I've got. So it looks like I got 4 times 52, which is 108. And I left out the minus sign, so it'd be minus 108. And and now we have to decide whether or not we did it right or whether or not we did it wrong.
I vote we did it wrong.
Because I probably didn't take out the right answer here. Okay, so minus 4 is right. That's right. Okay, so I got 10.
Well, I think
I got a 0. I got a 0.
When you multiply 4 by 52, you should probably get 208.
Oh, there we go. Thank you very much. That was Ben over there telling us that we're totally whole. So use your calculator to do simple math at all times. Unless you're the instructor and you can do it in your head and get it wrong on purpose so that the class can figure it out. Okay, number 7. I want to know, basically, the question boils down to, is it an imaginary number or is it not? So that's what the question is boiling down to. So can I factor this? 3x squared minus 8x minus 17. And that doesn't look like it's going to factor. So x is going to equal, well, plus or minus 8. Plus or minus the square root of 64 minus 4 times 3 times minus 17 divided by 6. All right. So am I going to have imaginary roots? No, because I have a positive number over there. Are my roots, am I going to have exactly one rational solution? No, that can't happen, because for that to happen, this has to be 0, and it doesn't look to be 0. So now, is what in the radical, is that a rational number or an irrational number? That's the issue. So 64 plus 12 times 17 is 268. And I go second function, square root of 268, and I end up with an irrational number. So the square root of 268 would be irrational, so that would be A. But I would get rid of 2 of the answers before I did anything else. And then if I didn't, if I wanted to just guess, at least I'd have a 50-50 chance, right? Yeah, probably. All right, number 8. Guess I'm just too impatient. Well, let's see now. I want to take 3 times r squared, which is 64, but it's not. It's not r squared. It's r to the 2/3, so it's really the cube root of 8, which is 2, squared it, which is a 4. And then the square root of 9, which is a 3, divided by 0.02. All right, so that looks like 36 divided by 0.02, which would be half of it with 2 more zeros. And so it looks like the D answer would be correct. Unless somebody has some objections to that, we'll move on. Huh?
I just remember that answer.
Oh, yeah, you remember, didn't I tell you that yesterday? You'd have all the answers memorized? I told you that. The rest of you, that's unfair. The rest of your classmates can't do that. You know? But no, Ben's going to have all the answers memorized. Except he won't remember the answer, he just remember it's D.
That's right.
Yeah, and then he remember D, and the D answer will be the wrong one. Fine.
No, do that. That always screws me up.
All right.
Oh, you will now.
There we go. Now we got to find that the 3 significant digits. Okay, that's fine. We can do that. Log 852 plus log 28.7. Can we use natural log and do this?
Yes.
No. Yeah. If you did, you would get it wrong. Yeah, we'll cover that pretty soon. As soon as I quit laughing after that last response.
I'm glad. It's just so hilarious.
Yeah, it's just totally amazing. Okay, it looks like I've got minus 13.2. So the issue is, if I have the log base 2 of 10, that's equal to the log 10 divided by the log 2, and it's also equal to the natural log 10 divided by the natural log 2. That's the case where I can substitute logs and natural logs. But where I go and I have an addition sign and a negative sign sitting there, now I can't do that. If I did, I'd get the wrong answer. Yeah, so that's why that is. Now, you could rewrite the problem. So let's say I rewrote the problem to be the common log of 852 times 28.7 divided by the common log of 8 divided by 17.2. That would be the same problem. If I did that, then I could substitute natural logs and have the same answer for that problem. But why would I want to overachieve? No. Maybe I would go to in Eric's class. I'd want to overachieve there. But, all right. Well, this is a secant problem. Isn't that lovely? 4 significant digits, and we want 0 to 2 pi. All right. So the first thing we would say is this is going to follow a cosine guy that looks like that, and the secant function goes like this. So if it's minus something, that means it's going to be down here, and I'm going to have answers there and there. No, 0 to 2 pi. I'm going to have an answer there and there. So I'm not going to, this is not an answer that's less than 2 pi. So I'm going to have 2 answers. I'm going to have a second quadrant answer, and I'm going to have a third quadrant answer. So that's what I'm looking for. Okay, so I do that first. And then I say, well, secant theta is 1 over cosine theta, implies that cosine theta is 1 over minus 1.26446. All right, so now I can go, what can I go? I can go in arc cosine of 1 divided by minus 1.26446. Okay, Okay, I put it in my calculator right, and I got that theta is 142.265 degrees, 4 significant digits. All right, so I'm going to round off to 142.3 when I get done. There is no 142.3. You notice that? Is that cool? So, but I want to be in radians. Shit, I want to be in radians. Okay, well, put the mode in radians. Radians. All right, now I'm in radians. Arc cosine of 1 divided by minus 1.624446. Okay, I got it in now. All right, now I'm in radians. So in radians, my answer is 2.483. So that would be D, except if you put down D, that's going to be marked wrong because there's 2 answers. All right, so this is the second quadrant answer. So now we're going to look for the reference angle. So the reference angle is pi minus 2.483. And then the third quadrant answer is pi plus the reference angle, which is going to give us what we have there. Okay, so I got pi minus 2.483 equals, and then I'm going to add that to pi, and I'm going to have another answer at 3.800. So I have 2 answers, one there and one there. Okay, wasn't that fun? You had to reach back and, oh, never mind what you had to do. You wouldn't have done it anyway, right? You just would have marked one of them and worked on. And,
That's right.
yeah.
I'll cut my losses.
Yeah, cut your losses before anything gets worse. Carmen is pulling a wagon. Okay, so I got to have a wagon. Okay, I got a 42-degree angle rope on with the ground. Okay, so that's good. With a force of 25 pounds. Find the vertical and horizontal components. Okay, well, I only want the vertical one. So the vertical component is 25 sine 42. All right, well, that should be easy enough. 25 times sine 42. Oh, I'm in radians. I get back into degrees. Back in degrees. 25 times sine 42. 16.7. Do I have a 16.7? Yes, I do. Isn't that nice? A. So not all of the right answers will be taken away. Only the ones on the harder problems. 12. A crank. Crank handle that long, horizontal position, blah, is rotated uniform blah, 6 revolutions per second. 6 revolutions per second. I need to have that in radians per second. So that would be 12 pi radians per second. All right. And now the issue is the handle is 18 long. So what's the equation of the curve? 18 sine 12 pi t a. All right. That fast enough for you? We will. The answer is C, right? Sine squared plus cosine squared. Doesn't matter what's there. Yeah. So the answer is C. So this could be sine squared of 45x cubed plus the second derivative of y minus sine 3 plus cosine squared of 45x cubed plus the second derivative of y minus sine 3. And it's still going to be 1. So So sine squared plus cosine squared is always 1, assuming the thetas are the same. All right. Right as in trigonometric form. All right, well, first of all, we need to know what quadrant am I in. I'm in the third quadrant because they're both negative. The angle is going to be 45 degrees as a reference angle, and 45 degrees onto 180 is 225. So these two answers are totally wrong, and that answer is wrong too, because I need a square root of 2 to be in there, so that'd be D. So R is going to be square root of 8 squared plus 8 squared, which is square root of 2, 8 squared, which is 8 square root of 2. And so the answer is going to be D. But by just figuring out what quadrant I'm in, negative x, negative y have to be in the third quadrant. That gets rid of 2 of the answers. Again, I have a 50-50-90 way of getting it right. 15. Well, this is a circuit analysis 1 question. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Which one is the right answer? A, right? So if I wrote it 1 over R1, well, R total is equal to 1 over R2 plus 1 over R3 plus 1 over R1, or whatever direction, then I know that's R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R2, R1, right? And so it has to be A. I don't have to do anything. I already did the problem in circuit analysis 1. It's already there, sitting there. Now, I could go and solve the problem. All right, so I'm going to overachieve 1 over z. Okay, so 1 over z, 1 over x, y, w. X, 1 over y, 1 over w. What's my common denominator? X, y, z, right? X, y, w. So I'd have y, w over x, y, w plus x, w over x, y, w plus x, y over x, y, w, 1 over z, x, y, w over yw plus xw plus yz, y whatever. And then I'd flop everything around, and the x, y, w would go on top, and the stuff on the top would go on the bottom. But I shouldn't do that, because it's just I'm just adding resistors in parallel, and I should see that. Okay. What are we doing next? Hope it's easy. 16. Add the sum of these measurements using the rules for addition. Okay, so I'm to the thousandth there, I'm to the hundredths here, I'm to the thousandths there, I'm to the 10,000ths there. So my answer can only go to the hundredths place. All right, now I take up my calculator, it's not on, that's not an 8, 8.523 plus 18.24 plus 9.096 plus 0.0952, and I end up with 34.9542, but I can only be as accurate as my hundredths place, 34.95. Okay, good enough? 16. I have a right triangle. Really? I want to know the hypotenuse of the right triangle. Alright, so square root of 34 squared plus 53 squared. Second function, square root, 34 squared plus 53 squared, close parentheses, 62.968 centimeters. And I only have two significant digits, so I'd go 63 centimeters. Okay, so that was 17. That was 17. And it looks like we should do two at the same time here. Speed things up. We don't really have to speed things up. I just don't want to get too bored, right? Nearest hundredth of a degree, and because it's not giving us a range, whatever our calculator gives us is correct. So we're going to take the arc sine of 1 over 1.2564, and I'm pretty sure my calculator is already in degrees, but I'm looking at it just to make sure. Yes, it is. Arc sine 1 divided by 1.2564, boom, and I want it to the nearest hundredth of a degree. Okay, 52.74 degrees. Graph the equation. Graph the equation. All right. Well, when x is 0, y is going to be minus 6. So we're going to be here at minus 6. When y is 0, x is going to be 4. So there's 4, and there's my straight line going through them.
You're going to have a hard time reading down that little line that you give us.
I think that when I do this, I go and there, perfect. Yeah, I normally leave room there. I don't on the study guide. I don't leave room, but on the test I leave room to do that. Yeah, so don't be missing that one. All right. So maybe we'll get a better problem to do. I doubt it, but this is Tech Math 2. I mean, we don't have hard problems in Tech Math 2. Haven't you noticed that? Ben hasn't, but okay, now it says solve and check, and what that's telling you is that you might, because I'm going to square something in here, I might end up getting an answer that won't work. Okay, so x minus 8 times x minus 3 is x plus 2, x plus 5 by cross multiplying. So I got x squared minus 11x plus 24 is equal to x squared plus 7x. Yeah, 7x plus 10. All right. The x squareds go away. And I've got to bring that over on the other side. Minus 18x is equal to minus 14. So x is going to be 14 divided by 18. 7 divided by 9. All right, so 7 divided by 9 is my answer. And I look over there and I say, well, that could very well be. Okay, so 7 divided by 9 minus 8 equals, divided by parentheses, 2 plus 7 divided by 9 close parentheses. So on one side I've got a minus 2.6. On the other side I've got a 5 plus 7 over 9. And I'm going to divide that by parentheses 7 over 9 minus 3. Or minus sign. Minus 3. close parentheses, boom, minus 2.6. So both sides of the equation is minus 2.6. So I've checked my work, and there wasn't anything funny going on. But there could have been something funny going on. There just wasn't anything funny going on. All right, now let's hope that because I put this problem on the study guide, you will never see it again until Tech Math 3. Okay. So I recognize the bottom as x squared plus 4 times x squared minus 4, and I recognize that as x squared plus 4 times x plus 2, x minus 2. Those with better graphing calculators would be able to do this in their calculator without any problem. So this has to be ax plus b c d. And now I've got to solve for a, b, and c. Well, I guess that's what I have to do. Ben's shaking his head. Now, I guess I won't get done with the study guide today anyway, so I guess I'll have to do that. All right, so I've got ax plus b times x squared minus 4 plus c times x squared plus 4 times x minus 2 plus d times x squared plus 4 times x plus 2 has to equal whatever is on the top. X cubed plus 33x squared minus 12x plus 108. Okay, so that's the problem I'm solving. And do I have a... Oh, I don't think I can solve it in this calculator. All right, so I won't try. All right, so back to what we're doing. So I've got ax cubed minus 4ax plus bx squared minus 4b plus c times x cubed minus 2x squared plus 4x minus 8 plus d times x cubed plus 2x squared plus 4x plus 8. All right, so I've got, all right, well, that's probably good enough. So I look at the x squared term, x cubed term. I've got an a, I got a c, and I got a d. And I see that they have to add up to be 1. I look at the x squared term, and I see I've got a b, I've got a minus 2c, I've got a plus 2d, and I see that that has to equal 33. I look at the x term, and I've got a minus 4a, I've got a plus 4c, I've got a plus 4d, and I see that that adds up to minus 12. Okay, and then I look at the unit term, and I see I've got a minus 4b, I've got a minus 8c, and I've got a plus 8d, and that has to equal 108. Okay, so assuming that I've done it right to that point, I can look at those and say, oh, gee, I'm so hosed. How am I going to calculate that? And of course, my calculator doesn't do a 4x4, so, but it does do a 3x3. So I'm gonna go in. Okay, that'd be okay. I'm going to take this guy and say A is equal to 1 minus C minus D. Okay, and then I'm going to plug that back into that guy. And I'm going to write minus 4 times 1 minus c minus d plus 4c plus 4d is equal to minus 12. Okay, so I got minus 4 goes to the other side, and I get a minus 8. I get a plus 4, and I get a 4, I get an 8c. I get a plus 4, and I get a plus 4, and I get a plus 8d. Okay, so c plus d is equal to minus 1. Okay, so I got one equation, two equations, three equations, and three unknowns that I can just put in my calculator. All right, solve system of equations. Turn on. All right, solve system of equation 3 by 3. All right, so I'm going to put in a 1, and I'm going to put in a minus 2, and a 2, and a 33. And then I'm going to put in a minus 4, a minus 8, an 8, and a minus, no minus, and a 108. And then I'm going to put in a 0, a 1, a 1, and a minus 1. And I'm going to tell it to solve it. And I'm going to have that my b is equal to 3. And my c is equal to minus 8. And my d is equal to 7. And then I come back up to this equation, and I get that a is equal to 1, minus a minus 8 giving me 9, 9 minus 7 giving me a 2. And so my final answer is going to be 2x plus 3 divided by x squared plus 4 minus 8 over x plus 2 plus 7 over x minus 2, if I remembered it right. Did I remember it right? Yes, I did. Now, at this point, who wants me to look at the key? Anybody wants me to look at the key? All right. Everybody wants me to look at the key. 10 extra points on the final if the key is wrong. What do you think?
The key is wrong. It's for 4.
If the key is wrong, then you guys get 10 extra points on the final.
Okay.
Extra credit points. So is that fair? Huh?
Is that per problem?
No. Yeah, I'm looking.
Wait, is that 10 extra points against us or for us?
Yeah, 10 extra. Oh.
Are you like adding?
Yeah. I'm gonna add 10 points to your score on the final if the key is wrong. All right. So I'm looking at the key, and no one's gonna believe me, right? If I say, "Hey, yeah, I got it right." Yeah. So who's the most honest person in the room?
First of all, we're not going to wait for me.
So Nate's the most honest person in the room. Is the key wrong?
No.
No, he's not wrong. Oh, I guess that means we're out of time today, and we'll have to finish the study guide tomorrow.